I actually won't be leading. Got my friend Bailey to come and teach you a little intro to AWS hacking. He's a DSU alum and used to teach for a little bit and worked in MATLAB, so he definitely knows what he's talking about. But yeah, I'll just hand it over to him. And
Sweet. Thanks, Tucker. Welcome, everyone. Thank you for your attendance tonight. So this has become a topic that I have really delved into in the past year. I want you to know that prior to January, I had zero idea what cloud hacking even meant. Never touched AWS, never touched Azure, GCP, any of that stuff. So let that be an encouragement that you can learn a lot in a small amount of time. But this is going to be an introduction to AWS hacking. What I hope to get through tonight is a little bit of what it actually looks like practically, but go over some theory with you and just some tips that I've learned in my time. And even give you a nice little story of a real world assessment I did a few months ago. So a little bit about me, quick. First and foremost, I'm a Christian. That's where my identity lies, and I go to West Center Baptist here in town. No doubt that the Lord has had His hand steady in my life, and it's definitely the reason I'm still here. But yeah, I am a husband and a father to my beautiful wife Amanda and my beautiful twins that are now a year and 3 months old, Bennett and Ruby. They are so much fun. Can be a lot for sure, but I enjoy them, and it's awesome to have them as a family, and I get to work from home. That does come with its cons, especially with babies screaming. But that's been my life over this past year. Like Tucker said, I am a DSU alum, so I came here in 2017. I'm from Georgia, so if you hear a little bit of an accent, that's why. But I came here for cyber operations, bachelor's, and I graduated with that in August of 2020, and then got my comp sci master's in May of 21. So I work primarily in the space of offensive security consulting. I love red teaming. I love pen testing. I like hacking. That's really the big thing, but not for the reason of just being able to be like, cool, I can hack things. I like to help clients make their defenses better, right? That's the whole point, and that should be the mindset behind red teaming and ethical hacking in general. We don't want to be the bad guys. We want to be the good guys. And there is so much. I mean, Miles can tell you, when I worked here at DSU in the ARL, we had the privilege to be offered the SBA grant from the White House, being able to test small businesses, network pen test or network application security. So we did network pen tests a lot, and I can just tell you for sure that there are so many small businesses and mid cap and large cap businesses that need offensive security assessments. However, the con of that is that they're expensive, understandably so. So we as offensive security consultants have to be aware of that and keep that in mind when you are setting up contracts for clients. So worked from 2021 to 2025. This year in January is when I left Dakota State, and I went to go work for Cisco, doing federal work pertaining to some of their cloud offerings that they have. And that is where my introduction to cloud started. So in the end of December, beginning of January, I spent basically a whole entire month of my life dedicating every single hour of my day to what the heck is cloud pen testing. So that was a huge, huge jump into a new land for me, and it is really cool. So now, unfortunately, with all the federal cuts that have happened, so did my contract go out the window, and so now I'm self-employed. And I've been doing contracts here over the past few months. So I do have my Office Security Certified Professional certification from OffSec. I don't really consider myself an expert. You can, I guess, say I'm a professional in some regard, but I'm always learning new things. That's the thing. With this field, you have to keep learning new things, and don't be discouraged or feel like you have imposter syndrome with that, because I feel that too, even with as much as I know and what I've seen in the workforce. But no, everybody else is on that same playing field. I did get a newer certification called the AWS Red Team Expert certification from Hacktricks Training, and that is where I delved into the whole world of cloud hacking, is getting that certification. So overall, why the cloud? Why why use any cloud services? And first off, who can tell me what the cloud even is? Come on, don't be shy.
Computer.
Yeah, Malcolm.
Someone else's computer.
Someone else's computer. Bingo. It's not just a server that we necessarily can just access. It's somebody else's server, generally, that you are able to access, and you're using their resources. They're handling all the hardware stuff. You just get to use the benefits of all the software. And being able to kind of plug and play nicer hardware at times. So generally speaking, when we think about setting up as a company from a business perspective, there is a phase in the business planning where you have what are called enterprise resource planning deployment models. Big word there. But what it looks like is just determining if you're going to have on-premise cloud infrastructure or a mix of both. And there's even models within Fortune 500s that they use multi-clouds for everything. So how your business is laid out in time, you have to think about these things, and there's pros and cons to each. Obviously, the pros of on-prem only, being able to self-host things, you have full control over everything. But it can be high cost, slow scaling, and there are, I guess, physical security risks. You can just put on a vest and walk into a building and say, I'm the IT guy, and it works. But hybrid cloud, you have a mix of both. You are using on-prem resources, and this is something that especially Microsoft has pushed in some regard to people that have on-prem domain controllers, being able to use Intra Connect to connect to Intra ID, which is essentially the cloud Active Directory, and use the benefits of both. Now, there's flexibility in that, but the con is that there's a lot of complexity that goes on behind the scenes to make that stuff work. And you are exposed to data sync vulnerabilities, and this has been an issue, especially with Intra itself. But this has been adopted by a lot of organizations, about 58% based on the stats I was able to find. Or you go with the other model of just full on cloud, right? You use a provider like AWS, you do a pay-as-you-go model, you just give them your credit card, and then whatever they determine or the pricings of what you're using, you pay for a lot of infrastructure. And there is kind of a myth with this, but cloud is actually pretty expensive, which is why we have seen in very recent years that after the COVID pandemic, there was a huge shift to like move to cloud, and now people are pushing back of doing a hybrid or on-prem model because of how expensive the cloud model can actually be. And there is also the con of shared responsibility, which I'll talk about that in a minute. But cloud service providers, that is what you would call them, CSPs. The big three are AWS, Microsoft Azure, and Google Cloud. You have others like Alibaba, Oracle, IBM, DigitalOcean, but AWS is definitely the largest. It has the largest market share of any of them, with around 30%, Azure 20%, and GCP 11%. So why do we hack the cloud, or why hack it in the first place? So because of this shift to the cloud model in the recent decade, we've seen a lot of changes in how engineers work from both a security perspective and a development perspective. So that's one major focus I want us to realize is that a lot of developers, they don't tend to really think security first mindset. Okay, we would call this DevOps. They just try to get their code out, they push it to production or their staging environment, whatever. But then there's this concept of DevSecOps where you introduce that security first mindset. You try to eliminate every single possible step of where things can go wrong prior to it being pushed to production. And there's a battle that happens in this, in the real world. I saw this at Cisco. There are dev teams that are hired across the world, okay? Especially a lot of them are coming out of India right now. And what is happening is that you have security engineers, right? When you're working with federal applications, they're in the United States. So you have these engineers that are outside of the United States, not really thinking security first about things. They're just trying to get the work done. They are using packages that are either outdated, they tend to contain a lot of security vulnerabilities. They are not pushing good code. And so security engineers on the other side are like, well, we need to fix this, but they have to tell the dev team to fix it, like when it's in the code. So there are, in the whole entire CI/CD pipeline of things, there are definitely plenty of steps where a security engineer's job comes in, but this is where you can learn a lot just from a cloud perspective, being able to apply the security principles that you've learned here at DSU to cloud and become a security engineer on the defensive side or on the offensive side. There is both. So hacking the cloud, just to give you some statistics, 45% of all data breaches typically are involved with the cloud in some way. 80% of cloud incidents are preventable via better configurations. I cannot tell you how many times I have seen, especially Cisco, but other things, other places where there are some of the craziest simple configuration mishaps that happen in a production environment. You're just like, how was this pushed either to production, or who did you hire to like make all this stuff happen? Because I mean, I'm not saying that I'm like a know-it-all or anything, but in my 1 month of learning about cloud, I was able to understand a lot of security mess ups that apply to a lot of organizations that are around today. And that goes to show that statistic is that, I mean, part of this huge shift to cloud really quick, you have a lot of these people who don't actually understand what they're doing with cloud infrastructure, that they tend to misconfigure things because they don't understand what they're actually using. So onward 94% of enterprise orgs have at least some workload in the cloud. That's definitely true generally with even newer companies or small companies. They don't want to host their own infrastructure, so they use cloud resources. And yeah, so the thing I like a lot about cloud hacking is just the fact that it combines so many different aspects of hacking into one thing. Like you're not focused, I'll reframe this for you. You're not focused on actually hacking AWS itself, okay? There are people that do that, and generally they're AWS engineers themselves. But you're focused on hacking an organization who is using the infrastructure of a cloud service provider and trying to find the flaws in how they have set up their own environments within this cloud service provider. But definitely from an external perspective, you are focused a lot more on misconfigurations with networks or REST APIs, web interfaces that they have, and trying to find bugs in those to get you to a point where you can find a real vulnerability to pivot into the cloud. And the nice thing about like all of this stuff is that it's generally public. I mean, when you are using a software as a service application, like that is being hosted likely on a cloud infrastructure, So if you find a bug in that, you can pivot likely to the cloud if it's a serious enough vulnerability. So back to the shared responsibility model, when I'm talking about hacking a specific thing on AWS, we are introduced to this concept of who is responsible for a security incident or a hack that happens. Is it actually AWS or is it the client? Generally, it's going to be the client, and this is what you agree to when you use these service providers. You agree that it is on you to configure your environment correctly, and it is not AWS's fault if your environment gets hacked. Which, of course, I mean, in my mind, that makes sense. But because AWS support isn't necessarily always there to help you, you can easily misconfigure things as AWS is huge. So AWS itself has over 200 services. Okay. I cannot tell you every single service AWS has. I don't know what they are. I just know that it has a lot of different things, and they come up with new stuff every single year. And the key services that you need to know generally are going to be IAM, Identity Access Management, EC2, Elastic Cloud Compute, ECS, Elastic Container Service, which is defined with task definitions. These are containers. Simple Storage Service is S3, which can be also used for websites. Lambda, which is serverless functions. I'll explain that one a little more later. API Gateway, this is how you expose certain endpoints, being able to be called to trigger some AWS service. VPC is the networking inside of AWS. RDS is databases, so like Postgres, MySQL. EKS is definitely a lot bigger now than it used to be, as many development teams have started to use Kubernetes as an orchestration platform for containerization, like Docker. And then Secrets Manager is used for storing secrets. So just think of it kind of like, I mean, Bitwarden in a way, but just in AWS. And so here is an example diagram of what we say are AWS architecture diagrams. You will see these when you are meeting with clients a lot, because this is what they use to map out everything they're using in their environment. It's super useful to know, but it also can be very tedious and annoying to look at because there can just be so much going on. So you have to break down with the client generally in the intro meeting. We're going over infrastructure. Now this is from a pen test angle. You have to go over like how their infrastructure works, how it interacts with each other, so on and so forth. Now, from a red team angle, if you're doing like a full black box test, that can be very difficult to map out what exactly is going on behind the scenes. They could be using a multitude of AWS services that you don't even know they're using, and that can lead to more time needing to do discovery, reconnaissance, and generally you're wanting to help the client figure out their flaws within the AWS application itself that they have configured pretty quick. And a full red team test is not always the best approach, full black box. But let's go into AWS just a little bit with what we start with AWS organizations. So organizations, just think of it as like you can control, if you're familiar with Active Directory, you can control different groups called OUs, organizational units, and apply those from top-down perspective. So if you have a manager of an OU, like they can create sub-OUs that can manage those OUs, and so on and so forth. It's a big tree. The organizational root account is the gold mine of the whole AWS organization. If you can get access to that account, which generally is not the case, most of the time you're going to be doing any type of cloud hacking. You may get an administrator of an OU, but you may not get the full-on root level account because that's pretty well protected most of the time. And there's not really a way to pivot to that without knowing the full email password and multi-factor authentication that goes with it. But that's just how generally a AWS account is set up if you're using AWS organizations, which most companies are going to be using. Then you have the concept of ARNs and policies. ARN stands for Amazon Resource Name, I believe, and I can go to this link real quick. Let's see. Copy. Because I do want to show you what this looks like. Okay, so in terms of AWS, what you have are Amazon resource names, and these names they're set up in a specific way. Okay, so you have a ARN, which is what starts it, partition, the service, the region, account, and resource. And what that looks like in practice is down here below. Generally, you have ARN, AWS, IAM, and then you, depending on what it is, may have a certain account. It may have a certain role attached to it. You can have or you can set this up for multi-factor authentication devices. But this is how it's able to identify everything inside of your AWS account, is by these ARNs. So these are very important. When you're looking through an AWS organization, you need to note down, especially within IAM, the users and groups and roles that are there in the organization. Now, when you go down further, you see these are just different examples. But in terms of ARNs, sometimes these are associated with keys. And going all the way down, these keys on the left side are indicated with a 4-letter start prefix. And each of these determines what the specific name or unique identifier is for. So you can see AKIA is always going to be an access key, which we'll be using. But you can also find users or roles, AIDA or AROA. So these are important when you're looking through the organization. You need to find like these specific identifiers. If you memorize this table, which I haven't memorized all of them, but a few of them, you can recognize immediately, okay, well, this is what this is, or this is what I'm looking for. But that's just a little side tangent on that. By the way, before I get too much further with this, if you want to follow along when I get to the live demo part, I do recommend going to AWS and signing up for the free tier now if you want to, because you do have to go through the setup process and give them your card information, whatever. But the free tier gives you like $200 of free credit to play around with, and free access for like 6 months. And you don't have to pay for AWS access anyway. You get a free account. It's just that after that 6 months, you're going to be charged money for anything you're using in the account that it comes with a cost. But go back to my presentation quick. Okay. All right, so policies. AWS IAM policies, there are a few of them. Identity-based policies, these are attached to IAM users, groups, and roles. Resource-based, these are attached to specific resources like S3, SQS, SNS. And the difference between these, generally identity-based is like you're applying a specific permission set to a user or group or role and what they can do in AWS. Resource-based is you're applying that same model, but you're also allowed to put in what are called principles and defining who is allowed to access that specific thing. Permissions boundaries, these are pretty neat. You as a manager of an OU or a root account, you are allowed to set the maximum permissions on a specific user and what they're able to do. So if a policy gets attached to them where it's an overprivileged policy and what they can do, they actually can't perform certain actions even though they have that overpermissive policy. And the same thing applies with service control policy, where as an org or an OU, you can apply specific things, these SCPs, to that OU so that they cannot go out of that boundary. They have a maximum permission set and what they're allowed to do. And this is useful for controlling your organization because sometimes you don't want specific OUs like your HR department to be able to do something like an assume role call to the API. Like, it makes no sense really. But access control lists are a legacy mechanism for controlling access to specific resources, like buckets or the specific objects in the buckets. When you assume a role, you take on the identity of some role in AWS. You can have a temporary session policy applied to you. And depending on what that temporary session policy allows you to do, there may be limitations applied to that certain session that you can't go outside the bounds of, or it allows you to do specific calls, like say you want to assume something that has higher privileges, you may need MFA for that. So you can apply that MFA and you get the higher privileged role credentials. And then a trust policy, when you are assuming a role of somebody else, you can define who or what as a service can actually assume that role. So some tips for you, even though you're not probably going to use these anytime soon. Try not to use star in any of your policies because star can just lead to a lot of bad things. And generally speaking, star, you can just think of anything, everything can access. Use IAM roles instead of users. So we are going to set up, or I'll show you how to set up your root account, and then you set up a user inside of that account and create an access key. I'm going to bend my rules a bit here for tonight because for the sake of efficiency, but generally you want to create a user that can assume a role with some type of MFA so that they can have higher privileges. Avoid using the root account at all costs. Tonight I will use the root account because that's the only thing I have available to me at the moment. Be aware of using not statements. I'll get to that in a minute. Always grant the minimum permissions needed. So follow the principle of least privilege. Do not assign more permissions than are needed because there are so many AWS permissions and actions in AWS that many security engineers, even on the defensive side, do not realize they can be abused for something, especially for privilege escalation. But a lot of security engineers tend, for good reason, I guess, to get the job done, they apply over permissive things, which then they don't take out. So when a pen tester comes along or a threat actor on the external side, they come along, they see, oh, this policy is over permissive. How can I get to that person that can use this policy? Or do I have that policy attached to me? And if I do, here's what I can do with it, because there's plenty of documentation of how to abuse all of the actions that are there. Use built-in IAM policy simulator to test and avoid mistakes, the IAM access analyzer, and also understand deny in AWS always takes a precedence over the allow keyword. So let's go over some policies. This is what a policy looks like. They come in JSON statements, and they're always set up in this way. They have like this version 2012-10-17. Don't ask me why it is that, it just is. And that's always there. When you create the statement, you don't have to give that, but when you look at the statement, it's there. But you set up the effect, the principle, the action, the resource So in this first policy, what we're seeing here is what would be a resource-based policy. Can anybody guess what this is for? There's some hints in the ARN specifically.
See, S3, which is storage, right?
Yep, S3 is storage. And it says my public bucket. The reason it says my public bucket is because the action, well, one, the action is get object, meaning anybody can read the objects in here, which are files. But it's a public bucket because of the star that's on the end of that slash, my public bucket, and the principal is star. And the principal being star means anyone, even unauthenticated users of AWS, can access this bucket. And this can be intended. This doesn't mean it's a bad thing. But like if you're hosting a website in S3, this would make sense. You want people to specifically access certain things of your bucket for a website. However, there can be a problem when you have that slash star in the case you're trying to hide specific directories and the user does not need to have access to those directories. So a fix to this, if you don't want it to be public, you can have it more secure in this resource-based policy where you define, you allow a principal with the specific AWS account ARN of the account 1234567891012 with the role my trusted app role can get objects from that secure bucket. Okay, so try it. When I read a statement, I generally read from top down, but I tend to just see, okay, this is saying it's allowing get object on this bucket, but who is it for? It's for this principal. Here is an identity-based policy. So this is not, I don't think, well, this is not a bucket policy, but it's identity-based policy, meaning it can be applied to a specific user or role or group, okay? And it says, for the resource all, do any S3 action, okay? So this means I can get the objects, I can delete the objects, I can list all the buckets, I can list all the objects in those buckets. And the condition is saying from the source IP, not IP address. So when you read it, you're thinking, okay, well, I want to allow all S3 actions, but not from this specific IP address, which is right. But the thing about this is that when you read it that way and you use this not condition, it actually allows everybody else to do it. So anybody else that's not in that IP range can actually read and do all these S3 actions on this bucket. And this is a public bucket, at least, and that's a bad thing in this case. So the next one, or if you want to, I guess, oh wait, I didn't delete this, sorry. But this one, at least, is a my bucket slash I can delete object allow. Okay, but it's a not action. So what this is saying, if you're wanting to block an action, okay, you're saying I want to block delete object on this bucket. Okay. The problem with this one is that it allows every other action. So you can't perform delete object, but now everyone in this account can perform any other S3 action on this bucket. This is a service control policy with the intent to allow one user to use update user, because it's saying deny all update user except for the ARN of this. Okay. There's a problem with this though, and this is not a valid policy actually, and I wouldn't expect you to know this, but the problem is, and I've seen this happen in production environments where people confuse certain tags. So that AWS resource ARN right there, there's a problem with this because a user that ARN for user is not a resource, it's a principal. So to fix this, you have to use principal ARN instead of resource ARN. And when you use it wrong like this, it actually breaks the entire policy. So effectively, you're just allowing anyone to use IAMUpdate user. But then this one, you can also become confused because it looks very similar to this one, except the fact that it's not ARN not equals, it's ARN equals. So this, you have to think opposite of what you think, like when you're reading this, deny IAMUpdate user resource condition ARN equals whatever. You're, again, allowing every other person, every other user to do IAMUpdate user with this policy. And lastly, before we go into story time, I bring this one up specifically because it's very real world in what happens with accounts that allow you to assume a specific role or user in the environment. And what this is saying here, this is called a trust policy. And it's saying I want to assume role, allow anyone to assume role if they're in the account 9876543211098 root. Okay, that root keyword does not mean the root account, it just means anybody in that account. Okay, so anybody in that AWS account ID can assume this role that it's being applied to. That's a bad thing at times when you don't set this up properly or think through the consequences of doing this, because if it's a highly privileged role, you're essentially saying that any low privileged role, like it could just be a person that can only assume a role of another smaller role or mid-level role in this other account. But if they figure out that they can assume the role in this account, they can get administrative access in this account. Okay, so real world assessment. I want to take you through exactly everything that happened, the whole attack chain. So we had an assume breach model where we started on an EKS node, which is an EC2. So this is our initial access point. We have a shell, a C2 agent deployed on this. We then go into lateral movement with EKS service account token impersonation. The reason this is possible is because by default, when you make EKS a service to your use in AWS, the managed policy from AWS that's given to that specific EKS node actually allows for you to do service account token impersonation. Don't know why, it just does. So the person that's using EKS normally, that does not know about this, is opening themselves up to lateral movement in this way. So we were able to go from a low privilege service count to any other service count that we saw. And one of these service counts allowed us to create deployments. And deployments in EKS are just defined YAML where you can say, spin up this specific type of container, do this, do these actions in the container, blah, blah, blah. Well, we spun up a rogue one, a pretty over-permissive rogue EKS deployment, disguised it a little bit, made it seem like it was a legit one. But the reason we did this is because with AWS and EKS, to get persistence, every time that these developers would roll through a new production push, the whole EKS environment gets re-rolled. Okay, so that means anything you do on the EC2 is actually just ephemeral. You can't maintain persistence because it just gets destroyed. But if you create an EKS deployment where it's a definition of, okay, every time this is re-rolled, do this, you can gain persistence, and we continue to launch C2 agents in this environment. From there was another service account we impersonated that has EKS secrets. So not secrets manager, but EKS has its own secret store, and that had a GitLab personal access token. So now we have credential access to a GitLab instance. In our discovery of AWS VPC, so this is where networking becomes important, analyzing all the networking rules that they had, we were able to figure out through many different transit gateways that you can contact the GitLab from the EKS node and any deployments under that node. So that allowed us to contact GitLab, do API enumeration with the PAT, because we were able to authenticate to GitLab's API. We moved over to discovery of figuring out what's all in this GitLab instance. And we found we have access to every single production repository that's there. But there's also these instances of shared runners. These shared runners are very important because they are able to be used by everybody that uses that GitLab instance. So not just this client, but any other client. So there's possible cross-tenant exploitation there. However, we discovered that this GitLab runner is ephemeral, meaning it redeploys every time. So even if we got a reverse shell on it as it was spinning up a container of some sort, it would just die. And so there's no reason to really get a reverse shell on it. But we came to figure out that the shared runners were actually AWS ECS task definitions, which can have roles assigned to them. Okay, so we developed an exploit script, ran through, and found the task definition credentials, and we did this all in a red team way. This is why we had to make the exploit script very precise so we weren't discovered. But we got these credentials, and turns out the credentials attached to this shared runner are administrator. So we're administrator in the production environment of this client, okay? We don't stop there though. From there, having administrator access, we did secrets exfiltration, secrets manager. We get a Jenkins SSH key. We are able to SSH into Jenkins, which Jenkins, if you don't know, is a CI/CD thing. Being able to bring together like all these different environments and then push things out so that you have the production, the staging, the dev branches actually pushed out. But there was passwordless sudo on the Jenkins instance, which enabled us to get Jenkins secrets. From there, we could decrypt because we had the key or the private key to decrypt the secrets. And that got us the admin GitLab PAT to their staging GitLab and their production GitLab. And there's difference between the two because, like I said, with this, there was a government side and a non-government side. We were able to cross the boundary of outside of the government and get into commercial stuff, which I was not allowed to do. We're not authorized to do that, but we had the ability. And there were also secrets that contained access keys for the staging environment and the quality assurance environments of their AWS stuff. And leading to that, it all led to cross-tenant compromise because once we had the admin GitLab PAT, we saw every single other client that is using this application and all of their customer data, which is bad. Then AWS has a service called System Service Manager, SSM, where essentially you just it's kind of like SSH in a way, but you're able to remote into different computers. And like I said, there's multi-cloud use in a lot of organizations. They had domain controllers set up with Enter ID Connect inside of AWS. And so we compromised the domain controller and then attempted to do an LSAS dump, which then caused a denial of service on the domain controller because it lost resources. So that wasn't good. But we also then had access to customer data with their RDS instances. So that's just an example of like everything cloud hacking can lead to is when, from an external perspective, if you have a website that has an SSRF or command injection vulnerability, like you can be exposed to so many things. And it's a rabbit hole of so many goodies that I just love to dive down. So learning resources, you can go to my website and then resources cyber there. I have that there specifically laid out in different sections. One of them's cloud, and then I do have references here. But for the last 15 minutes of this, let's actually do some hacking. I'm gonna try to mirror my display so that I can show you what I have here. Come down here. Okay, so one of these resources that I have on my website is specifically Flaws Cloud. So Flaws, it's made by the security engineer that they basically have a public environment where you can just hack a cloud instance. And so what this is it's a challenge built for you to be able to run through and learn some of the basics of what it would look like to find, in this case, a public S3 bucket, and then dive deeper into that. So I'm going to open my terminal. And if you want to hack along with me, feel free to. This is all public, so you guys can access this too. Move this over. But know that you will need an AWS account for like the second level and onward. So through this, you can feel free to read this, but level 1 is, this level is buckets of fun. So see if you can find the first subdomain. Okay, so this is really a reconnaissance challenge in this one. I'll try to keep things up on the right and left. So when I'm doing DNS discovery, generally I like to use Dig. Dig is a good tool to be able to do DNS or find DNS records. And you can see that flaws.cloud does resolve to a lot of these A records. And within these A records, sometimes these A records can point to other subdomains. Okay, so it's good to be able to go through those A records themselves and get what they resolve to for pointer records, reverse DNS lookup. So we can use dig flaws.cloud, and I have my notes beside me just so I don't mess this up. I like to use the short flag just to get the IP addresses, and then use xargs with this little curly brace tactic, because it basically will go through each of the IPs in a list and then do a DNS reverse lookup on those curly braces and do short and sort U. That's another thing with cloud hacking, by the way. Becoming really good at Bash and knowing how to use Bash effectively can help you in so many instances. But we have this here. We have that 2 of the IP addresses resolve back to an S3 website. Now, if you go to this, it's not going to be anything crazy. It's just going to point you back to AWS if it resolves. Maybe this one does. Nice. Okay. But what it tells you overall is that the fact that it does resolve to S3 website means that flaws.cloud, what you see here, is an S3 bucket. Okay. And so because you know that, after finding what it resolves to, you can use the AWS CLI to query it. And to use the AWS CLI, you can go look up on Amazon's documentation how to install that. If you're on Linux, they have a few things for you to be able to install that pretty easily. There may just be an apt package if you're on Debian. But if you're on Mac, Brew has it inside of its repository, AWS-CLI, I believe. But with AWS, I can call the S3 service, and I can say ls S3, S3 as the, what is it called, schema, and go to flaws.cloud. And what you'll see is that it says I have an authorization header malformed when calling list objects v2 operation and on AK ID. So I didn't provide a credential. Now, the reason it's mad about this is because I have AWS installed, and AWS by default, when you use AWS as the CLI, it tries to look at your default configuration profile that you have in your computer. And that can be found at cat.aws config and credentials after you create or when you install the AWS CLI. To get a credential, you need to get an AWS account, but for this challenge, you don't need that. You just need to also append a flag called no sign request. And by the way, when you're using anything AWS CLI, tab is your best friend because it will allow you to tab complete through. So no sign request. And you can list the contents of that bucket. Now, to look at the contents of the bucket, this may seem unintuitive, but you can use the copy command in S3 and copy piped in, or not piped in, but to standard input, which is just dash here. You can copy whatever is in there into standard input. Now, I didn't give it a file. I'll go back real quick. What was that file? Secret DD02C. So let's see. So I'll go here, copy that, and we will get the HTML back for that page, which tells you where level 2 is. So going back here, I can go to level 2 now. And this is where you would need to create an AWS account. Now, these levels tells you what the lessons learned, examples of the problem, avoiding the mistake, showing you how to fix it. But level 2, you need an AWS account. So once you're signed up with AWS, you can look up AWS amazon.com/console, and you can just sign in. And I'm going to sign in with my root account. Remember, not the correct way to go, but I'm doing it for the demo's purpose. And you will need to do this the first time you log in, but I have MFA set up with that. And then we can go to the search bar up here and just type IAM, which will bring up the IAM service. So on the left side here, you have your different access management tabs, users, roles, policies, etc. You'll want to create a user, and I'll go ahead and create a user in the top right here. But we create a user by setting up a username. So for this, I'll just say it's for flaws. Go to next. And this is where you want to be very careful. Is what permissions do you give your user? For the demonstration purposes, I'm going to give it admin because you're going to need different types of permissions that you may not know of yet. But just understand that if you do set up admin with this, and by the way, anything that has this little orange block beside it, that means it's an AWS managed policy. It's preset policy configurations. Administrator access is dangerous if you leak your key anywhere, okay? So do not push your secret key ever to GitHub, very bad. But we can create this and have no console password or anything, but we can create the flaws user. So we can click on that, and you can go to security credentials and give it an access key right here. So we create the access key. You want to do command line interface. Go to next. Go. Oh, gotta click I understand. Don't give it a tag, it's okay. And then we get the access key. Now, what you do with this is in your CLI, there is a command within AWS called configure, and I'm gonna configure a profile called flaws, and I'm gonna give it an AWS access key, and you'll see my secret key for just a second, so please don't hack me. I will delete this afterward, but you'll give it a default region name, US East 2, and we can just do a JSON output format. Now, I didn't mention that with regions, but regions are actually pretty important in AWS. So I'll go back to IAM real quick. What you'll see in the top right is that it says global right now, but you have regions specified to certain services. So if I go to EC2 as an example, you'll see that it will default me to Ohio, which is US East 2, because we are in the Midwest and that's where we're closest to. If you get a different one, that's okay. Just make sure you note down what region you're actually assigned to. Okay. So I have this key now. And what I can do with this is I can now have the profile called flaws be used as that key. And that is now in the credentials file after you have used configure. You don't have to use configure. You can just go to the credentials or config and set it up. But we can now go to the flaws level 2, copy the domain here, and delete the HTTP schema, and use, with the profile flaws, S3LS on that. And it will allow you to see what the secret is in here. And this is just an example of, it won't work if you're unauthenticated to AWS because the principal set on this bucket, the bucket policy it has, says that any AWS account can access it. So again, we can use copy flaws.cloud, secret HTML, and standard input, and we get to level 3. So I am going to stop here because level 3 actually does take a bit of time and it's really annoying. But I do encourage you to walk through this. This was just to get you started. To walk through flaws, but once you get done with flaws, and there are walkthroughs online, so if you want to watch a video, feel free to. On my website, I also have other cloud resources. Flaws 2 is the thing, and that goes even deeper than Flaws 1 does. But there's AWS Goat, and there's Cloud Goat, there's EKS Goat. Each of these things that allow you to set up and Terraform files and push to your AWS account where you can have vulnerable things inside of your AWS account that you hack yourself. Now, if you are wanting to go the route I did and pay a little over $1,000 in certifications here, Hack Church Training does have their cloud certifications, and it looks cheesy, but man, is this a wealth of knowledge, and I promise you that because I went from knowing nothing, like I said, to knowing a lot, and eventually, thankfully, it gave me the skill to be the expert on my team when I was working at Cisco, and so much so that my boss still wants me back, and that's just awesome. Like I can give praise for that, and it's a great resource to have if you have the money to do it. But obviously, I know that you don't have the money to do that as a college student all the time, which is why those other resources are there. So with that, 7 o'clock. You can leave if you want. Are there any questions? No. Cool. Well, thanks for coming, guys. If you want to see more of this, I can definitely come back and even go through more in-depth stuff. But thanks for coming, and really hope that you get into this because it's awesome.